Hey, good morning, guys. So I thought this might be a little easier, a little more efficient, so I don't have to worry about like sharing my screen. And it's unfortunate I don't have like the calculator to bring up, but I will try to go through some calculator steps that you can try to do on your own at home. Okay. So we left off yesterday in class by beginning to talk about this problem that addresses a sample of 1,100 males between the ages of 12 and 17 in the U.S. And they were asked whether they play these MMORPGs, these massive multiplayer online role playing games. Of the 1,100, 775 said yes. Okay. We're asked to come up with a 95% confidence interval to allow us to estimate the true number or the true proportion of all U.S. males between this in this age group that play these games. All right, so we have sample data to kind of come up with that generalization about every U.S. male between ages 12 and 17. So our parameter of interest, we kind of talked about that yesterday. Our parameter, right? Let me just make sure I have this writing tool up. There we go. Is the true proportion of U.S. males 12 to 17 that play these games. The conditions we talked about yesterday too. All right, some similarities to what we've been talking about the last few chapters. But in order for us to actually do this inference, for us to construct a confidence interval, we have to check a couple boxes here. The sample needs to be random, all right? And it is. We're told that an SRS is taken. The sample needs to satisfy that 10% condition, meaning 1,100 is definitely less than 1/10 of the population, right? There's a lot more males between 12 and 17 in the US, so it's definitely less than 10%. And then finally, the large counts condition, right? So not so much memorizing large counts. I would more so focus on this third condition, kind of speaking to normality. Because once we do means, this name will change. All right. So the large counts condition basically says that your number of successes, those that answered yes, and the number of failures, using those terms loosely, the number that answered no, both those have to be at least 10. If they are, this condition is satisfied. So prior to moving forward, we got to make sure that those three are all squared away. All right, we kind of left off here yesterday. We know that from the formula sheet, all right, from the video. Let me just flip back real quick and I'll show you. All right, you find a confidence interval by finding the statistic plus or minus a critical value times your standard error of the statistic. We talked about the right side of this plus or minus being what's called your margin of error. But what is the margin of error comprised of? Critical value times standard error. All right. Now, your critical value is dependent on your confidence interval. Most of the time, we will do one of the following: a 90, 95, or 99% confidence interval. So these critical values will be repetitive because I've already seen them. All right, but here's what I want you to think about how you find these numbers. If we go back to our normal bell-shaped curve and we think of the middle 95%, right? And we know that there's 2.5% in each tail. We want the corresponding Z values. So we've done this, it's just been a while, but these Z values, right? One's positive, one's negative. We want to find that Z value. So we can use our calculators, all right? And if we did menu 5, 5, and then inverse norm, so 553, and it asked for area. But remember, area in the calculator reads left to right. So I'm not putting in 95%. I don't want the middle 95. I just want this tail. If I want to find this z value here, I need the area that's in this tail, which is 0.025. Leave the mean and standard deviation as 0 and 1, and hit OK. And because you did the leftmost tail, you will get a negative number. And if I round the 2 decimals, it would be negative 1.96. But our critical value, let's just say it's always going to be positive. Think of the absolute value of it, right? So plus or minus 1.96, that's our critical value, and will always be our critical value for 95%. Again, to do that, I did menu 553, inverse norm. My area was the left tail, and I left the mean and standard deviation as 0 and 1. Now, our standard error. Let me go back to the formula sheet. So it's the square root of p hat times 1 minus p hat divided by n. All right. So again, p hat here is our sample proportion. Our sample proportion is 775 out of 1100. Which is about 70%, 0.705. So I think it's fair to say we can round to 0.7. All right. So that would be those that responded yes out of our total. All right. So times the square root of 0.7 times 0.3 divided by our sample size. Okay. So I'll find that number first just so I can kind of speak a little bit to that. But if we did the square root of 0.7 times 0.3 divided by 1100, right? We would get something about 0.0138, right? Times 1.96, our critical value. Well, it actually asks us to find both, so I guess I should write them separately here. So our critical value is 1.96. Our standard error of p hat is roughly 0.0138. And guys, I don't care if you go 3 decimals or 4 decimals, but that's how you would find that. Now, we could find our confidence interval by hand using our statistic plus or minus the critical value times the standard error, which I will set up for you, but I think that I'm also going to show you the calculator, and wait till you see how much less time and effort that is. All right. Where are we here? So if we have to construct this confidence interval, our statistic, right, that's our sample, our point estimate, that number would be 0.7, right? 0.7, 775 out of the 1100, plus or minus 1.96 times 0.0138. All right, so let's do that real quick. All right, so in doing so, I got my lower bound of my interval to be about 0.67. I'll go 3 decimals, 0.673, and the upper bound of the interval to being 0.727. So that means that we are 95% confident.
You got the reflex? Thank you.
The interval that we just found, the interval from 0.673 to 0.727 captures, contains, I like both those words, captures the true proportion. And from there, I will stop writing and just put a little dot, dot, dot. Captures the true proportion of who? The true proportion of U.S. males between ages 12 and 17 that play MMORPGs. Okay? Now, real quick, I want to go back to here. Rather than going this route, menu, 6, 6. So menu, statistics, confidence intervals. And then there's a bunch of them to choose by. Now, what we have here is proportions, okay? And we only have one proportion, right? We only have one sample. So you will scroll down to 5, 1 prop Z interval, all right? And it's important that we write that down somewhere on the AP test. If you remember from the video, you have to acknowledge what type of test you are using. Hey, Liv.
Okay, my fruit.
Oh, yeah, here's your fruit. Here, go ahead. You're welcome. All right, so if you hit menu 665, you're going to be asked 3 things. The first is number of successes. We have 775. N was 1100. The C level, or confidence level, or interval, 95%. So that's the default. So you don't have to change anything there. Just hit OK. All right. And in there, you will see your C lower as well as your C upper. Now, ours vary a little bit. The reason for that is just rounding error, right? I rounded this only 2 decimals to 0.7. You'll notice that it's a little bit more than that. I rounded this number, okay? And that's why the calculator is always going to be more accurate. And that's why we want to go this route. And using technology, using the calculator, it would have been 0.678 to 0.732 if we went to 3 decimals. Okay, but as long as you show your work, whether it's by hand or it's through technology, both will work. All right, guys, so give a look to this video, and I think it'll help us moving forward. All right, thanks.